Hey guys, this is our second to last video of the semester. First thing we're going to talk about is transformations of functions. And then we're going to get into something that is totally new for you guys. It's pre-calculus curriculum. We're just going to get in the very basics of that. And then this is it. So just make sure you guys are watching the videos, you're taking notes. The worksheets are there for you guys to print off. And let's get started. So first thing we want to talk about are parent functions. So the parent functions are the ones that you are just the general functions. It's the simplest function with the defining characteristics of the family. So functions in the same family are transformations of their parent functions. So these are the parent functions. When we add transformations, it's part of it. It's the same thing. It's just transformed. It's the best way I can explain it. So first thing is a constant function, meaning it's just a horizontal line the entire way. Then you guys are familiar with a linear graph. And so it's just f of x equals x. This is a parabola, a quadratic function, which is x squared. This is what we call a cubic function. So it's degree 3. This is a square root function, and then these are reciprocal functions, so 1 over x. Really for the ACT, I would at least kind of memorize what these are. As far as your go formatives and that kind of stuff, it's not that deep, but for the ACT, I would make sure that I'd memorize what these functions are. A lot of them you've seen before and you're very familiar with. Some are kind of new, and that's okay. Parent functions and transformations. Two more to talk about. This is an absolute value graph. And then here are integer function graphs. We're not really going to use this with transformations, but you will see absolute value a lot. You will see quadratic a lot, cubic, and probably square root. So those are the 4 major ones that you'll see a lot. All right, this is going back to freshman year of Algebra 1. Vertical transformations are when you add or subtract a value to the whole function. So you're adding some number at the very end of function. Horizontal transformations are in parentheses. They'll always be in parentheses with these types of functions. And they're always the opposite. And I'll show you what I mean when we get to another example, when we get to an actual example. It's just you always change the sign. So that's the big thing to remember here is that you're always going to change the sign. Reflection over the x-axis, the whole function's negative. If it's a reflection over the y-axis, you're just going to change the sign of the x value. And then dilations, you just multiply by a number in front. So if it's a vertical dilation, meaning it's stretching or shrinking vertically, so you're stretching vertically, it's a number that's multiplied in front of the function. Horizontal dilations mean it's getting fat. You're going to multiply the x by a number. So I'm going to show you what I mean. I know that's a little confusing if you don't remember this stuff from freshman year, which was a while ago. So we're going to look at some examples. So you should be able to see this here. All right, so if we look at this one right here, it's x minus 1. This is a horizontal translation because it's in parentheses. And we do the opposite. So instead of left 1, this is going to be right 1. So this sign, if it's in parentheses, is always going to be opposite of what it looks like. So negative, I would go to, remember, we look at our number line, I would go to the left. But because it's changing the sign, we're going to go positive right. All right, for B, I have a negative 5 added to the end. So if it's into the function, it's a vertical translation. So this is vertical. And it's negative, so negative is going down. So down 5. All right. Then I look here and I've got a negative in front of the function. So a negative in front of the function, it's reflected over the x-axis. And then here, let's look at, there's 2 different transformations first. Easiest one always is this one, added at the end. It's positive, so it's up 7. And then this number in front, it's out in front. So it's a vertical dilation. And if it's greater than 1, it's going to expand vertically. So it's going to expand by 7. So this is going to be an itty bitty quadrilateral. It looks something like that. All right. Let's look at another one. This one's just matching. So here it says it's a quadratic function. So x squared. It's expanded horizontally by a factor of 2. So it's kind of tricky because a lot of times these two do the exact same thing. So, and honestly, I kind of ignore the horizontal dilations. I just focus on the vertical. And I know that if it stretches vertically, it's going to shrink horizontally. So horizontally, it's going to get skinnier. Or if it shrinks vertically, it's going to get fatter horizontally. Okay, so I think about, really, I'm crushing it. So if I have Play-Doh and I smush it, what happens? It gets fat. And then if I stretch it out, it's going to get skinny. So you think of it the opposite way. So I think for this problem, it says it expands horizontally, meaning it's going to shrink vertically. And to shrink vertically, it's got to be less than 1. So it expands horizontally by a factor of 2, or you could say shrinks vertically by 1/2. So that's what this piece does. And then it's translated 7 units up. Remember, up and down is always at the end. This is a cubic function, so raised to the 3rd power. It's reflected over the x-axis. Reflection always goes at the very beginning. And it's translated 9 units down, which again goes at the end. Absolute value, here's our signs. It's translated 3 units up. Again, up and down is always at the end. And it's translated 8 units right. Remember, left and right goes in parentheses, and you change the sign. So since right is positive, instead of putting +8 in parentheses, we're going to put a -8 in parentheses, or in the absolute value sign. And then this just says a reciprocal function. You probably won't see this one a lot, but it says it's translated up 1. We just add 1 to the end. And that's pretty much it. That's the main parts for the ACT we're going to focus on. So next thing is trig functions. It is new. It's a bit scary and overwhelming, but that's fine. We're only going to look at the basic parts of it. It's not everything you need to know for the ACT, but at least you're familiar with what a trig graph looks like, and it'll help you out there. So make sure you do your Go formative, and I'll talk to you soon.